workshop is about industry engagement. And what that means we see on this slide here. In the SUNRISE project, we create a safety assurance framework for highly connected and automated vehicle systems. And in this workshop, we would like to increase our focus on the industry users of our framework. So that's what this workshop is designed for, as we will see in the subsequent pages. Here's the team working together on this workshop today. The first person I'd like to introduce you is Julie Kastermans from Ertico. She is organizing these workshops, and I am personally moderating this workshop. My name is Stefan de Vries, and I work for IDIADA in Spain. Then also with me on this workshop is Jason Tsang from University of Warwick. He leads a key task on our project. And also John Frederick Grunwald from Chalmers Industry Technique. He is leading a key work package on our project. Let's also take a short peek into the near future. For example, the next workshop, which will be in January 2025. In that workshop, we will showcase an online interactive version of our handbook of that safety assurance framework. So hopefully that will be of your interest and we can see you there again. And if not, there's also the possibility to join us as a possible user of our SAF, of our safety assurance framework, during the final event on the 18th of June 2025 in IDIADA headquarters in Spain. In that final event, we will present the theory and the practice behind the safety assurance framework to its main target users. So hopefully we can see you again on one of those events. So now, before we start with the actual presentations, I'd like to express some comments. So first of all, you as external experts on this call are encouraged to provide your feedback on the things that we will present to you today. And that will be feedback on your personal behalf, not necessarily on behalf of your organization. We value your opinion, your suggestions, your ideas as an expert in this field, not necessarily representing your organization. Also, we will not use or reference to you personally during the further course of the project. We will anonymize any feedback that we get from respondents. So hopefully that will enable you to express yourself freely without without being limited in your expressions and your feedback. There might also be some SUNRISE partners on this workshop. They are encouraged to listen and hopefully maybe also to facilitate the discussion that we're having today. Also, for your information, each workshop will be recorded. The presentation parts will be published. They will become available to you after the workshop. And the discussion part that we will have later will not be published. That's only for our internal reference to make sure that we correctly capture your feedback and address that in our project. Then the presentations of this workshop will also be shared afterwards. You don't have to take a lot of screenshots today. If you have any questions during the workshop, just raise your virtual hand here in Teams, and then you will be given the chance to speak. Okay. So let's go to the agenda then for today's workshop. I'm now doing the welcome, and I will soon do the SUNRISE project introduction on a high level. And after that, my colleagues John Frederick and Jason will take over to explain the current version of the safety assurance framework, the main product of our project. And after that, you as audience will have some time for questions. And after that, we enter into the session that is most important for us. That's the question and answer session, where we raise questions to you as individual experts on CCAM, and we hope to provide you can provide us with some interesting feedback and answers to those questions. So that will be led by Jason a little bit later in this workshop. And then about 2:30 we will start closing this workshop. So that's the agenda for today. And with that, I'd like to show you a short introduction to the SUNRISE project. And let's start with the main goal of the SUNRISE project, and that is to develop and provide a harmonized and scalable CCAM, Safety Assurance Framework, and CCAM stands for Cooperative, Connected and Automated Mobility, a term you might have heard in other occasions, especially in the area of EU-funded projects. Also, we will abbreviate the Safety Assurance Framework to SAF to make it a bit easier. So SUNRISE itself stands for Safety Assurance Framework for Connected and Automated Mobility Systems. And the runtime is in total 3 years. We started in September 2022 and it will end in August 2025. So we still have about 8 or 9 months to go. The total budget being 13.5 million euros almost, completely funded by the European Commission. Now, if there's one key liner I would like you to remember, it's the following one. The decade-long debate in scenario-based assessments now converges into a common basis. That's exactly what we're doing in the SUNRISE project in a very summarized way. So hopefully you can remember that phrase and take that with you. Now, this safety assurance framework that we are creating in the SUNRISE project is quite an abstract and intangible topic. So for that reason, we created this vision image to give a better understanding of what we're doing in this project. So here you see this centralized role for the SUNRISE project and its safety assurance framework. And you can also see that there's different stakeholders in society that each have their own interest in that framework that we are creating. For example, vehicle developers might ask us the question, what scenarios should I test my automated vehicles for? Or certifiers and regulators might ask us, how should I assess the safety of automated vehicles before I can release them onto the public road? Then researchers might ask us, how can I compare my automated vehicle results to those of others working in this field? And tool developers might ask us, how can I make my tools fit to those of others in this field? So to those questions and many others, the framework that we are creating in our project is trying to provide the answers. And we do not do so alone. We do not operate independently. Actually, we're based on a predecessor project called Head Start. That's the foundation of the SUNRISE project. And also we align with our twin projects V&V Methods in Germany or our Japanese twin, the Sakura project. And also, as we will see later, we reach out to scenario databases that can connect to our framework. For example, the TNO Streetwise database or the Safety Pool initiative by University of Warwick, but also others that can connect to our framework, as we will see later. So here you see the work plan that we take in our project. And again, here's the central role for the safety assurance framework that we are developing in our project. And here you can also see that this framework is based on mainly 3 components. One is the method, for example, a method for scenario selection and allocation, but also a method for rating procedures and creating safety metrics. And then there's a tool chain, for example, for virtual and physical evaluation of scenarios. And on the other hand, there's the data framework. And many people ask us here, okay, a data framework, but is that another scenario database? And then we clearly say no, creating another scenario database is not part of this project in SUNRISE. Instead, we provide a layer to which scenario databases can connect so that the user of our data framework can connect through our framework with many scenario databases that are connected to our layer. But these scenario databases are external to the SUNRISE project. So there will not be another scenario database developed within the SUNRISE project, although another scenario database of importance is now being developed under the Synergies project, which is very much related to SUNRISE, for example. So this data framework serves kind of as a hub to connecting other scenario databases. And that data framework will have its own structure and governance mechanisms, and it will also have its own ontology that allows for querying the databases that connect to it. So altogether, this forms the safety assurance framework. And this safety assurance framework is now in a stage where it's quite mature. As we will see later, we have a mature version of the safety assurance framework, and we are now going to put that framework to the test. Inside our project, we selected a number of relevant and realistic test cases to put our own safety assurance framework to the test. That's what we're entering into now in this last phase of the project. So finally, this will result in a number of technical results and demonstrators. As you can see here, a few examples, and I would like to highlight one, and that's this SAF handbook that we are currently finishing and almost publishing the first version. So as mentioned before, in January, we will have a workshop in which this handbook will be published on our website, and it will be first presented in that workshop in January. So stay tuned for that. I hope that will be of your interest. At the very bottom of this work plan, you can see the entities to which we try to engage and hopefully even make them adopt our SAF, our safety assurance framework. Those are entities like UNECE or the European Commission and its member states, or consumer testing agencies like Euro NCAP, but also the industry with its vehicle manufacturers and its suppliers, as we have with us on board in this workshop today. So engaging with them, explaining our results, but hopefully also making them convincing them of really starting to adopt our framework and apply it. That would be the ultimate goal to reach here. So now let's have a look at the partners on board of our consortium. Since we are a 100% European funded project, of course, most partners come from European member states, and there's also a partner from UK. So together we form the SUNRISE Consortium. And again, in this consortium, you can see those different types of stakeholders that each have their own interest in the safety assurance framework. That is actually reflected in our consortium. We have, for example, researchers on board. We have OEMs and their suppliers and authorities. They're all represented in our consortium. And as I mentioned before, we reach out to external experts like you on this call, and also to related initiatives like the ones I mentioned before. And let's have a little bit closer look at those related entities and projects that we're reaching out to. Since the start of the project, we've been making sure to align with twin projects and initiatives around the world on this topic of safety assurance for CCAM systems. Of course, there's many initiatives out there, and one of the goals of SUNRISE is to align with those other initiatives worldwide to make sure that we create a harmonized safety assurance framework, not just another one, not just another silo, but really a harmonized one that is aligned as much as possible with other initiatives around the world. And those are initiatives and projects like AVSC, the Automated Vehicle Safety Consortium in the United States, which represents a large number of US automotive stakeholders. And Transport Canada has also been advising us about our framework. Then there's the V&V Methods project, our big brother within Europe in Germany. And there's the Sakura project, our Japanese twin. Also an initiative by the South Korean government from the Katri Institute. And also we have been reaching out to CARS-Q initiative in Australia. So with that, you can see really in this picture that we're aligning worldwide to make sure this framework is harmonized, not just another silo. Then this is a part of our team. We got together last October for our General Assembly. In total, we are 150 people, and this is just a fraction of them, but perhaps you recognize some of these people on this image. Now, with that, I conclude the introduction to the SUNRISE project. Later, you will have time to ask some questions, but first I'd like to give the floor to Jason Zhang and John-Frederick Grönwall to present the current status of the safety assurance framework. So go ahead, Jason and John, to present this part of the slide deck.
Thank you very much, Stefan, for the introduction. Do you see my pointer? Yeah. So I will start with a few minutes on the where we are in the work package 2, the central CCAM safety assurance framework. And as Stefan said, we are here in this work package developing the methodology for safety assurance of the products. And we are not creating the metrics and the judgment for that. That you have to remember, this is the methodology for a safety assurance framework. So in the work package, we have first made an inventory of the existing assurance frameworks. And as you saw in the previous picture here, we are collaborating with all the other important projects worldwide, like Sakura, for example. After the inventory, now we are in the process of developing the SUNRISE safety assurance framework with a harmonized way of doing that. And that is what we later on will present in today's presentation. The deliverable from this task in this work package will be next summer in June 2026 with the deliverable 2.3. Deliverable 2.1, the inventory is already available. And secondly or third, once we now have this safety assurance framework relatively mature, we're now already also developing the Safety Assurance Handbook, an interactive web-based tool for all the users to be able to use it publicly. And it will be beginning of next year or end of this year, actually. We will have it available on the SUNRISE web page to be able to download. The first version should be available then. And then during spring, when we have the safety assurance framework further developed, and also with the comments from you in industry and all other stakeholders, there will be an update that will be available then during the final event in June. What we also aim to do in the safety assurance framework is to stress test and to include a few of the test cases that we are doing in the project, also to run through the complete safety assurance framework. As you will see in a couple of minutes, there is a very stringent methodology to run through the safety assurance framework. And we believe that this is how we could also present it in the safety assurance framework. And by that, I will hand over and ask my colleague Jason Zhang at Warwick University to take over. Thank you. Please, Jason.
Yeah, thank you, John Frederick. Thank you, Stefan, earlier for the introduction as well. So I will take over the slides. Yep. So basically, now let's unpack what's in this red box, which is the central of the SUNRISE project. So that is the safety assurance framework. And then, so during this process, we actually aligned with quite a lot of existing national, international, and regional standards and the initiative or some ongoing effort. So one of such is the UNEC NATAM pillar, the 3 pillars. One is the audit, and the other is the safety performance assurance, and the other is the in-service monitoring and reporting. So all 3 pillars are key part of the safety assurance framework. Although during the SUNRISE project, we are actually going to put a more emphasis on the central part, which is the performance assurance. And then in the end, you can see at the bottom, we have the input layer to all the 3 pillars, which contains our ODD information, the behavior, and any other external requirements you might have, and also the exact test objectives for your specific testing. So now if we have a look at the central pillar, actually, what we conclude that to perform a performance assurance, actually you only need 3 main blocks. So the first one is the scenario, and then the second is execute, and then the third one is the analyze. So essentially what it means is to perform a performance assurance process following a scenario-based approach underpinned by ODD and behavior. So that's a quite key phrase, because if you're scenario-based, testing process is not underpinned by ODD, you could actually pass all your scenarios, but then your scenario might not be actually relevant to your existing ODD for the system. So this input layer interaction to the performance assurance and really to all the three pillars are actually quite key. So so essentially what it means in the central part is you need to have a set of scenario to test, and you need to have a execution environment to execute your scenario. And a lot of us coming from the virtual testing point of view, you might automatically think about the virtual environment, but really in here from the framework point of view, we are thinking of all possible environment, that including X in the loop, and that including the real world test execution. And then, so once you have the set of scenario, once you execute in your intended test environment, or it could be several, if it's not only one, then the last stage is to analyze your execution outcome and to be able to derive the conclusion whether your system has passed or not passed a specific test. And if we want to now further unpack these three boxes, let's first have a look at the scenario block. So scenario block actually contains create, format, and store. So during our early stage of the literature review and information gathering stage, we realized that really to create scenarios, there are many methods, and each individual organization actually have documented in the literature in the past. But if we want to really summarize where they belong, actually they belong to two different branches. One is generating scenarios based on knowledge, and the other is generating scenario based on data. So data-driven approach, you might have heard quite commonly. For example, you have your national accident database, or you might have a CCTV recording footage. So those are already pre-recorded data, and you then use that data to actually derive further scenarios, or maybe to recreate what the data has captured using scenario format. So that's all falling below the data-based scenario generation approach. But on the other hand, you might also want to actually utilize existing experts' knowledge. So for example, you might have experts in ADS architecture designing, and then without any exact specific available data, the expert might already be able to identify quite a lot of the weak point in a new given SAOT system on the test. So in that case, we might already be able to derive a set of scenario based on such knowledge. And just to emphasize, knowledge-based approach not only limited to, for example, utilize experts' knowledge, but the fact that you might have the system's ODD and you might be able to derive scenarios from the ODD, that itself is also a knowledge-based approach because it's independent from any specific data. So basically we realized that the creation of the scenario actually broadly you can always categorize into these two categories. But then at the end of such creation, we might not need to actually conform into a specific format. So some organization might use a specific data structure, or some organization might even use Excel sheet or some other format, or even a written recording, just a handwritten information. So really, to make such information exchangeable and shareable across the industry, we actually need to adhere to standard format. Some very well-known format in the industry, we can say a lot of synergy is the ASEAN Open Scenario XML, Open Scenario DSL, and also the ASEAN Open Drive. So paired the Open Scenario with Open Drive, this is one of the common format for simulation execution. But the format might not only targeting simulation. The format might also targeting human consumption. So in that case, we actually during our expansion, of the explanation of the SAF, we have recorded at least 4 different levels for scenario abstraction. You have the functional level, the abstraction level, and then you have the logical level and concrete level. So each of the levels are quite key, and we need a robust conversion across different levels to be able to exchange the same scenario information between human readability, between machine executability, and between anywhere who might be sitting in between these these two levels. And then after you have constructed your created scenario in a standardized format or in a few standardized format covering different abstraction level, and the next step is to actually host that in a scenario database. So as Stefan mentioned, that the scenario creation, the formatting, and the database is outside the SUNRISE scope. However, they are definitely part of the safety assurance framework because the creation, the formatting, and the storage are key elements of this. And you might also heard there's an other ongoing project, for example, the Synergy might be actually tackling this exact stage of the safety assurance framework. Yeah, so then once we have got all the scenarios in a qualified scenario database, by saying qualified because SUNRISE, if you remember what Stefan mentioned, we focus on this common layer, and this layer will allow multiple databases to be connected. But not all the database who wants to connect can be connected because we have set quite a few standardized requirements for those databases. So for example, you cannot just provide any form of scenario format. You have to adhere to standards format, and you have to adhere to specific query, and we got a whole list of requirements. So given that your database is willing to connect and meeting the requirements, then such database could be exposed to the SUNRISE federated layer where external can then perform the next stage. So the next stage actually is called query and concretize. So basically, yeah, in a few slides time, you will be able to see a human interacting with the SUNRISE safety assurance framework, especially the performance assurance level, how it might look like. But to give you a little bit of a spoiler alert, the query and concretize is actually the entry point where you would interact with the federated layer. So essentially, you will receive input from the bottom input layer. Let's assuming that we have a set of ODD and behavior requirements. We want to do motorway, we want to do day, and we want to do night, and we have cutting, for example. So this will form your query requirements into the query and concretize circle. Query and concretize will then pass this information to the federated layer, and then the federated layer will then query individual scenario database to get the corresponding scenario and then pass back to the query and concretize. So that's actually what included in the first word of this stage, which is the query aspect. The next stage will be the concretizing aspect. So a lot of scenario during the scenario-based testing process, what you want, what is a common practice within the industry is you want to actually explore your parameter space, which normally is defined in a range. Let's assume that you have got back a set of motorway scenario during day and during night, following that example. And let's say one of the scenarios says we need to operate at 50 to 60 kilometers per hour. Then that is not directly executable because it's a range, and the simulation actually need a very unambiguous concrete value so that it can run. So this concretize actually act as such function to actually concretize a specific value so that we can then pass through the next few blocks for the execution. But then later I will come back to this concretize again to address the question. So if we concretize one value, how do we ensure that we covered enough between 50 and 60 to say that we have done this logical scenario? Yeah, so next stage, let's assume that we have got a set of scenario. We choose one to start with, and then we also concretized a specific parameter. Now the next stage, the scenario should be ready to execute. But then, as I mentioned before, we have a whole set of execution environment going all the way from pure virtual to X in the loop and to physical execution. And the allocation of the environment is another immediate next step, which before we can execute, we need to decide which environment we want to choose. So in the SUNRISE, in the work package 3, there is a dedicated task, which is mainly addressing to creating a mechanism for the scenario and the test instance allocation. But if I want to just cover at a very high level, you can extract a whole set of requirements from your scenario, from your external input at the bottom layer, which will represent those requirements towards the simulation environment, or in the SUNRISE, we call them test instance. And on the other hand, through the audit part, you would have previous knowledge on the available test instance and what is their capability. So basically, this whole mechanism is a list of questions and comparison to compare the requirements versus the capability. And we will then link the scenario with the least computationally intense test instance that can fulfill the requirements, and we can allocate to that test instance. But for further information, please follow up some of the deliverables in WP3 on knowing more on what's inside this allocate block. So once we have allocated, the next part is naturally the execution of the scenario. And the whole SUNRISE WP4 covers quite a lot on what are the simulation architectures that can fulfill the execution. So you can see very nicely how each individual block's work packages in SUNRISE actually are mapped and are addressing different part of this SAF framework. And post or during the execution, we can perform analysis based on the execution data. So two key aspects from the analysis are, one is called coverage analysis and the other is test evaluation. To give you a direct example on what's the difference between them is test evaluate, basically evaluate whether this specific test you have passed or failed, and also were in charge of, even before you actually go into the pass-fail criteria comparison, is whether your intended test scenario has executed. So let's assume that the same motorway scenario, and you want to do a cutting, lane change, overtake, and the lane change cutting. That could be a case where the pass-fail criteria has never been violated. However, that also not taken place a cutting scenario. In that case, the first step, whether the intended scenario has occurred, is actually no. So there's no need to actually even perform further pass-fail criteria comparison. But if it is yes, then test evaluate, this block will perform both the intended scenario occurred or not, this kind of check, and also check against the pass-fail criteria. So one note in here is we are not defining the exact pass-fail criteria in SUNRISE, because there will be, first, would be differ from case to case, and second, many of them might be inherited already from the input layer at the bottom. So the user would automatically already have in mind what is the pass-fail criteria. So we keep it open and at a high level from now, mainly covering different categories of such pass-fail criteria. So that's mainly the test evaluate. And let's have a look at the coverage. So coverage is looking at, for example, the question whether, let's go back to that example. If you have a scenario saying that on motorway you should drive between 50 to 60 km per hour, and then we have a concretized parameter 56.8, and you have passed. Now the coverage, one of the question coverage will answer is whether this single execution is sufficient to cover the whole 50 to 60, because in the end, we are saying whether the system has passed this whole logical scenario, which is actually represented in a parameter range. So if the answer is no, then coverage will need to actually feedback to this concretize to say that we haven't covered sufficiently enough, so we need a new concretized parameter. And so in the SUNRISE in WP3, we have also been covering so many different ways where you can actually do this concrete value sampling. You can do naive search, you can do intelligent search using optimization algorithm. So if you are interested, please go and have a look at our WP3 deliverable once they are ready. But this is one aspect of the coverage. The other aspect could be in the initial stage when you actually retrieve a set of scenario from your database. Let's take one extreme example. Let's assume you only retrieved one single scenario. Perhaps your database is very poorly populated and only give you one scenario. Coming back to our previous example, let's assume your query example is motorway, day and night and cutting, and then you use this set of keywords to query your database, and your database gives you one scenario back, which means motorway and day. And you pass that scenario and you pass the whole process, so that scenario is fine. And the other aspect of the coverage now is, have you covered enough of your ODD space from your whole scenario test suite? In this case, we could argue that highway, motorway at night is actually never covered in any scenario. So in that case, your scenario set is not sufficient enough. So that's another aspect of your coverage. And in the SUNRISE project, these are the aspects that we will document further, and we will organize another workshop around February 10 to actually addressing any further comments. So one of the to-do during the SUNRISE project in the next just less than a year also is to record a more detailed coverage and test evaluate block and their high-level categories of the things we want to check. And in the end, we have a decision box. So both the coverage and the evaluation box will go into the site. And another to do is we want to discuss within the SUNRISE project. But if you have any input, more than welcome. Is whether the decision is a simple conclusion or whether we want to have a more robust mechanism to have a decision making flowchart within this decision box. So that is something, if you want to know more, please stay tuned. We will have further details on the site. And the input layer actually interact throughout the whole safety assurance framework. So even outside the SUNRISE scope, let's assume into the maybe to a scenario creation team, ODD and behavior and external requirements can be used for create scenario, but also from the SUNRISE project, the second arrow is the entry point where you use those requirements to actually perform your query and concretize, mainly query in this case to the database. And your external requirements, your ODD and behavior can also be interacting with the analyze block and also can be used for your decision box. And the in-service monitoring, reporting, and audit are slightly less covered than the performance assurance during the SUNRISE project, but you can interact with quite many different blocks. So, for example, to capture scenarios that we might have missed during the initial performance assurance process, the in-service monitoring reporting can contribute towards the further abundance of our scenario database. So you might constantly capturing new scenarios. So in that case, we'll have further and further knowledge on missing scenarios. And also you might actually capture more evaluation matrix. So for example, you might actually find out that public perceived safety might be a key factor that we might have missed, but you have captured during the in-service deployment stage. And that's something, for example, you can then further input into your analyze block. And all of this process will also need to be audited. And also the audition, just to clarify, is not only limited to audit of what you're seeing here, but also of your organizational management process. So that's more on the team and the employee and the organization level. But in the SUNRISE, in this arrow, we are more focused on the technical aspect. I think that's pretty much a very quick walkthrough of the safety assurance framework. I think we can open the floor for questions from the audience.
And as Julie said in the beginning, we have the Q&A where you can post your questions, or you can also raise your hand. But please write in the Q&A.
Yeah, actually, I've seen already Carlo has one question. Yes, Devin, do you want to jump in?
Yeah, indeed, Carlo has one question raised already on the Q&A.
Yeah, so Carlo mentioned R ontologies. So R is a ontological format, is maintained and developed and managed by the W3C consortium. And yeah, so for your information, our ontology format is also being discussed, was discussed during the OpenX ontology concept project in the ASEAN standardization phase. So the question is, are all ontologies used in SUNRISE, for example, in the GaiaX project family, compare with this repository? And let me see if I can expand. Are standards like ASEAN, Modelica, Chronos group recommended, for example, the ASEAN OpenX for simulation and are the result made in parts open source, and can a user, for example, a developer or stakeholder, try out the process in the prototype? Yeah, so maybe I will dive into the first one. So the OpenX ontology is a, or maybe I will generalize our ontologies. I think we did not specifically focus on the format because this whole SUNRISE project is more around the safety assurance framework. So we do have a dedicated task which talks about ontologies that we can use for query the database. And in that aspect, we have actually surveyed quite a lot of existing past initiatives, that including the OpenX ontology, including the ASEAN Open Label, and including other ontologies. And I think the initial conclusion is, at least for this query to the database, the ASEAN Open Label ontology, or a simple taxonomy, together with its JSON format, is actually a quite good fit for the SUNRISE project. But we are also open to see more this kind of synergy being formed in the industry, and if there are good and better candidates, or if we need to actually suggest a further standardization phase to those already identified candidates, we are more than happy to actually discuss this possibility. OpenX for simulation. The second question, definitely it is a key emphasis for the whole simulation part. And I think if you are interested, we have some past deliverable around the WP4, which are around simulation architecture. And I think standards like Open Scenario Open Drive, Open Simulation Interface, Open ODD, Open Label are very heavily mentioned. So all the people in SUNRISE are also quite active, either user or contributor in the ASEAN OpenX family. So definitely the ASEAN OpenX. The other two, I personally, sorry, I'm not too familiar with it. So maybe we can follow up. And the third part are the results made available open source, and can a user actually try out. So I think this one, maybe Stefan and John Frederick, you can correct me if I'm wrong, but at least the deliverable of the safety assurance framework is at the framework level, but the WP7 will be the instantiation of the framework at the use case level. But for those use cases, the current intention is to share us a document style. I'm not sure whether we will be looking into a open sourcing of some code base or some tool chain. Yeah, so yeah, maybe Stefan or John Frederick, if anything I missed, feel free to jump in.
No, I think you're correct there. And we in this work batch, we're focusing on the framework itself, whereas we will run a few use cases through the methodology to test it. But the actual, as you mentioned, it's not covered, as you say here.
Yeah, and I think Carlo also followed up on the relation between R and also JSON format. Yeah, so fully agree. So if we can represent our metadata in JSON, we should be also easily convert into R format or other compatible format. Then we have a second question. Thinking in the categories, verification, validation, and argumentation, where would you place your framework? Yeah, so I don't know whether John Frederick, would you want to take this one? I also have something in mind how to answer this one, but maybe I'll begin with my thought, and then we can make it more of a conversational based, so we can actually jump in. So actually, this safety assurance framework, or you can always also call it a scenario-based testing workflow underpinned by ODD, is actually quite aligned with the VMV concept. So actually, I think this could be placed in the central part of that process, and the whole process. So this process representing from a vehicle developer point of view. So for vehicle certification body, for example, if you if you have already tested internally and you want to present your result to a vehicle safety body to verify, that might be slightly different focus compared with this, but at least for your internal VMV process, the performance assurance workflow should actually be quite aligned with the different stages of your VMV workflow. But then the audit part might be more aligned with, for example, the qualification of the tool chain, and also from a vehicle safety body point of view, how can they actually audit your whole process? How can they audit the result you presented during your internal development and the validation process? And so basically you can at least see from this perspective, the central part, from your perspective, from a vehicle developer or OEM point of view, could happen pre-certification. The audit might be at the point of when you interact with the vehicle safety body, and the in-service monitoring reporting might be something coming after, during your deployment. And so the whole workflow will work quite well with your internal VMV process. I don't know whether this answers your questions.
I think, Jason, it explains a lot, but it's both the audit on the top, but also the input from below, where we have the external requirements and test objectives, etc. So the central part is where we have the framework, as you say, the scenario, execute and analyze, the methodology for running through development and testing, etc. And then on the outer sides here, we have the inputs and outputs. So, and in a couple of minutes, we will also come back to questions to you also in the Q&A. Stefan, do you want to add something from your side?
No, I think you mentioned most answers already. Perhaps add that in the official contract that we have with the European Commission, we really have to focus on verification and validation through, for example, that simulation framework that plays such a big role in this whole safety assurance framework. That will have a major role to play, of course. We want to minimize the physical testing, but in the virtual simulation framework, we really focus on verification and validation. And then at the very end, in the decide block, we do the argumentation. So I would say all three categories are covered by this framework.